In Section 3, we are going to be learning about electron configurations. Here are your objectives for the section. Now, to help us learn these objectives, I have something a little bit special for you today. I have 3 former chemistry students that did a little video to explain all of this stuff to you. So let's take a watch.
Hi, I'm Carrie Brown. I'm here today to talk to you about electron configurations. Do you have any idea what those are? I didn't think so. The 2 confusing words may make you want to scream. But after I'm through with teaching them to you, you'll think they're easy peasy lemon squeezy. What is an electron configuration? Is what's probably running through your mind right now. Well, the answer to that is the arrangement of electrons in an atom. The lowest energy arrangement of the electrons for each element is called the element's ground state electron configuration. Real atoms are not built up by adding protons and electrons at the same time. Next, we'll be talking about 2 principles and 1 rule. The first principle is the off-bow principle. It means that the electron occupies the lowest energy orbital that can receive it. The orbital with the lowest energy level is the 1s orbital. In a ground state hydrogen atom, the electron is in 1s. 2s orbital is the next highest energy level. Then comes 2p. The second principle we are going to be talking about is the Pauli exclusion principle. This states that no 2 electrons in the same atom can have the same set of 4 quantum numbers, which you learned about in the previous section. Next, we are going to talk about Hund's rule. Hund's rule states that orbitals of equal energy level are each occupied by 1 electron before any orbital is occupied by a second electron. And all electrons in singly occupied orbitals must have the same spin state. 1 electron will enter each of the 3p orbitals before a second electron enters any of them. Now I'm going to hand it over to Nicole after the break.
Are used to indicate electron configurations: orbital notation and electron configuration notation. In orbital notation, an unoccupied orbital is represented by a line with the orbital's name written underneath that line. An orbital containing 1 electron is written the same way, with a line and the orbital's name underneath, but with an upward-facing arrow. Also, with an orbital containing 2 electrons, there is an upward-facing arrow and a downward-facing arrow. These lines are labeled with the principal quantum number and the sub-level letter. Electron configuration notation eliminates the lines and arrows of the orbital notation. Instead, the number of electrons in a sublevel is shown by adding a superscript to the sublevel designation. The hydrogen configuration is represented by 1s1. The superscript indicates that 1 electron is present in hydrogen's 1s orbital. The helium configuration is represented by 1s2. Here, the superscript indicates that there are 2 electrons in helium's 1s orbital. This shows the unoccupied orbital, the orbital containing 1 electron, and the orbital containing 2 electrons. For example, here for boron, you have your line with the quantum number underneath with the upward and downward facing arrows. Since there are not enough electrons to fill up all of the 2 p's, you just leave them as blank lines since they are unoccupied. Same with fluorine. These are the electron configuration notations. Notice the superscript. These are replacing the lines and arrows of the orbital notation.
Hello, my name is Allison Cosgrove. Today I'm going to be talking to you about noble gas configuration. Noble gas configuration is the outer main energy level that's fully occupied, in most cases by 8 electrons. It's a shorter version of the electron configuration notation. All group 18 elements are considered the noble gases. When you see electron configuration, you see how long it is. But with the noble gas notation, it's much shorter. It shows you the noble gas that comes right before the next element.
That's all.
Hope you enjoyed this.
Okay, awesome. Thank you, girls. Great job. Goodbye.